M1 Statics example 10. In this example, we have a box of mass 10 kilograms and it is in limiting equilibrium on a rough plane, which is inclined at 20 degrees to the horizontal. So I've drawn a rough diagram here. We've got to find the coefficient of friction between the box and the plane. Now there's one force I haven't put on yet. We've obviously got the weight and the normal reaction. I haven't put on the friction. You've got to decide when you're doing a question like this which way the friction would act. Now in this case, because there is nothing else holding the box up the plane, the only thing that is keeping it stationary is the friction. Therefore, the friction must be acting up the plane. Friction always acts to oppose motion. So if you've got an object that's unsupported on an inclined plane, it would naturally want to slide down the plane, and so the friction must be resisting that and holding it up the plane. So think carefully about the direction that you put your forces on the diagram. Nice and easy. We know again that this angle here between the perpendicular and the vertical will be the same as this angle at the bottom, which is 20 degrees. So if I was to resolve perpendicular to the plane, we know that R upwards would equal 10g cos of 20, which is acting downwards perpendicular to the plane. So working that out, it works out to be 92.09 newtons. If we then have a look at what's happening along the plane, again because it's in equilibrium, any forces acting down the plane will balance with any forces acting up the plane. Now the only force acting down the plane is a component of the weight, and so going in this direction we'll have 10g sine of 20, that's acting down the plane, will be equal to friction, which is acting up the plane. Now we know that friction is mu r, and it's equal to mu r because it's in limiting equilibrium. So we can put mu, and then 92.09 is the value of r, mu r. So dividing through by 92.09, you should find, when you do your calculations, mu works out to be 0.36 to two significant figures.